The Flextrolla problem extends the concept of the news vendor model to kind of a more advanced version, the make-to-order model. And the key to this problem is really understanding how the underage and overage costs are going to change once you introduce the option from XE. To start out with Part A, we're looking for the expected profit if they were to procure exclusively from XE. Let's start out by calculating the gross margin on those sold units. And we know that that Flextrolla makes $121 on each unit they sell. And if they're buying from XE, they're buying them at $83.50, which gives a margin of $37.50. Since we know that the forecast is normal with a mean of 1,000, we expect that sales will be equal to 1,000. Multiply that times this 37.5, and we have expected profit of $37,500. For Part B, to determine the profit maximizing order quantity, we'll need to compute the critical ratio. In this instance, the overage cost, the cost of ordering too many units, is equal to the cost of the units minus the salvage value. We know that if we purchase the units from Selectric, the cost is $72, and we know that we could then sell the extra ones at the end of the season for $50. Therefore, we have an overage cost equal to $22. The underage cost, or the opportunity cost of ordering too few, is equal to the price at which they need to purchase from XE mid-season in kind of a second order, minus the cost they would have paid Selectrics to purchase before the selling season. So we know that the cost of getting them from XE is $83.50, and the cost from Selectrics is $72. So therefore, the underage cost is $11.50. That's basically the premium on orders from XE over Selectrics. The critical ratio is then equal to CU over CU plus CO, and that's equal to $11.50 over 22 plus $11.50. That corresponds to a probability of 0.3433. Looking that value up in the standard normal distribution function table, we find that it is between the z-values of negative 0.41 and negative 0.4, but we'll use the roundup rule and conclude that the z-value is equal to negative 0.4. Finally, we can convert that into a quantity using the formula the mean forecast plus the standard deviation times z, which is equal to 1,000 plus 600 times negative 0.4, and that's equal to a profit maximizing order quantity of 760 units. Please look at Part 2 of this video for the answers to Parts C and D.